Since early in 2021, together with a firm of specialist offshore engineers, we have been developing TT2, a completely new concept of offshore tidal turbine specifically designed to address what we believe are the fundamental reasons why tidal energy has failed to keep pace with the development of wind and solar. It makes particular sense to develop this technology in the UK because we have a disproportionate share of the world's potential tidal energy resources around our coastline, meaning we could even export tidal energy to the rest of Europe. Following months of desktop work, which clearly indicated that we had the basis of a good idea, our next step was to build a 1/20th scale model, capable of proving the concept in a hydrodynamic testing tank. In April 2022, we arranged to test our model at the Marine Technology Park in Gosport, Hampshire, now owned and managed by Kinetic on behalf of the Royal Navy. The ship tank, as it is known, is a 270-metre pool with a carriage over the pool that moves up and down its full length on tracks at specified speeds, simulating the effect of the tide. In this picture, you can see the model having just been assembled, ready to be lifted into place and attached to the carriage. You will see that we have 4 foils on the left-hand side and 3 on the right. This is to establish which of the 2 most obvious configurations will start better and perform better. In this shot, you can see that we established very quickly that the 3-foil version is much better at starting. In fact, it started to turn as soon as the carriage started moving, as if the 2 are connected. The optimal configuration will ultimately be where the lift generated by the foils exceeds the drag that they experience to the greatest extent, and these initial runs seem to suggest that 3 foils work better. In these tests, we used robotic motors and ran them backwards as generators with very small, highly geared and very inefficient gearboxes that I feared would simply stop the turbines from turning. My team seemed more confident that they would still work despite the inefficiencies, and I was very happy to discover that they were correct. In this shot, we have attached the motors and we are generating electricity for the first time. I was astonished that despite the load being applied to the turbine and the considerable friction in those tiny gearboxes, the turbine only slowed down by about 10%. This proved beyond any doubt that vertical foils can generate enormous torque when placed in moving water. Here we have increased the speed by 50%, and the little motors produced numbers that were actually slightly higher than my team expected. In this final shot, we have changed the foils on the 3-foil version to the smaller 150mm size. The engineers were convinced that these smaller foils would perform better than the 200mm foils, and to my surprise they were absolutely right. The best performing configuration of the test was indeed 3 of the smaller foils. If the UK and the rest of the world are going to meet their zero carbon targets, a significant breakthrough in tidal energy must be found that is both economically viable, quick to develop, and enormously scalable. And following our successful test and many months of design work, we are now convinced that TT2 is this important breakthrough.